So we're working on a polygons on coordinate plane. And our goal for today is to find the area and perimeter of a polygon using coordinate plane, distance, and absolute value. But usually before we start, we always have something like to talk about. So you want to make amends for a silly misunderstanding with your best friend, best buddy, friend, classmate, or family members, whatever you are have misunderstanding. For example, would you rather write a letter to that person or talk to that person, and why? I'll give you a minute to think. And what do you think you're gonna decide? Go ahead, Alana. How will you do this?
I would rather do it in person, like talk in person, because if you write a letter and you use a word that has different meanings, they don't know what meaning. Or if you write something and you meant for it to be like in a nice tone and then they think it's a mean tone, they can misunderstand the letter, so they might not think you're trying to be mean or something.
Correct. I got you for that one. Selena?
I think it would. I think I would rather talk in person because it might be easier to say things and like explain it. Because in the letter you might forget to include some stuff.
Correct. I understand. Iman.
I would rather talk in person because, like, if you're talking, it'll be a lot more easier than writing a letter. Because, like, sometimes when you talk, you can't, like, write the exact same thing on a letter. Correct. So it'll be a lot more different.
Correct. Is there anybody in the group that says want to write a letter? Everybody want like just talk. I just want to share with you. In the other class, they said one of the students said, "I'd rather write a letter because I'm scared that she doesn't forgive me yet. So I'm not gonna see the reaction right away." So something like that. There are people that are scared in confrontation. One last, Omar.
Something I would do, I would first write a letter to the person, and then I would go over and then talk to them like that.
Correct. That's true, right? So everybody has different way of doing some mending. So that is cool. Thank you for that. Share, people. All right, so let's move ahead. So yesterday we did lesson 2.5. So today we're doing lesson 2.6. This is the last part of this unit. So we're doing exercise 1 today. Perimeter of regular polygon. Before I move forward to that thing, what is a perimeter? How do you find a perimeter? I mean, Selena.
Perimeter is the like length around a like polygon, and you find perimeter by adding the length and the width like 2 times.
All right, of that rectangular polygon. But if it is like any polygon, how do you find them, Alana?
You have to count the amount of units bordering the inside of the shape.
Okay, so we're just counting the corners. So whatever shape is that one, right? But here another word that we need to know. What is a regular polygon? Why is it called regular? Can I have somebody else like Andy? What is a regular polygon? Annie, let's take you.
I think a regular polygon is a identifiable shape, like per se a square, and no, not a square. There's some shapes that are not official shapes. It's just made up shapes, and those are considered irregular, and you want the opposite of that, which is to have an actual identifiable shape.
Okay, Tiffany, would you like to add what Annie said? What does she mean by identifiable shape? Go ahead.
I think a regular polygon are polygons with the same. The sides of this are pretty much all the same.
Okay, I could take that one too. Anyone else? Selena, do you have an idea what a regular polygon is?
Yeah, I like to add on to all of them. Like a regular polygon is like when all the sides and angles are equal. Like for example, a polygon, like a regular pentagon, is 5 sides and no more than that, or else it'll be irregular.
Mm-hmm. So what is a three-sided polygon? It's a regular one. What do you call that? Lana.
A triangle.
If I have a four-sided polygon, what will it be, Omar?
A rectangle, or I think a square.
What else? There are a lot of them that are four-sided regular polygon.
A rhombus.
Okay, what else? I'm squeezing your brain. There could be parallelograms, right? So
Oh yeah, parallelogram.
Trapezoids? Question mark.
correct. Yeah. So those are
Rhombuses, the diamond.
yes, those are regular polygons. All right. So let's see how they're gonna find the perimeter of regular polygon. Let's move this so we could see it because it's cut in half. Supposed to be.
How can you find the perimeter of a polygon on a coordinate plane? Think about this question during the lesson. An archaeologist used a coordinate plane to map a dig site. She marked the corners of a building with flags as shown. How much rope does she need to go around the building? How can you find the length of rope needed to go around the building? To find the length of rope needed to go around the building, find the perimeter of the building.
So we're gonna find the perimeter of the building, okay guys? I'm gonna post it.
Is there any extra information given in the map of the dig site? Explain.
What is the information that is in the picture that we don't really need to find the perimeter or how much rope we need for the building? Aiden? Selena?
Aiden?
Oh yes.
Who's that?
Yeah. How do you
Me?
say? Yes. Sorry, I mispronounced your name. But how do you say your name again?
Aiden.
Aiden. Go ahead, Aiden. See, this is what happened when we don't see each other, guys, too much, and I don't mention your name a lot. So Aiden, go ahead.
How do we find the perimeter?
Now, what is the extra information that we don't need in this picture? In just finding the perimeter of finding how much rope we need for the building, for the dig site.
Oh, food tent and a working tent.
Very nice. So those sometimes in a problem they usually give us like extra information that we don't need. What is that? What's the purpose of the problem why are they doing that? Omar, do you have an idea?
They're doing that so that they can trick us. Like a lot of the times they would do that and put extra information that we wouldn't need in a problem, so they could trick us or get us confused to make it harder.
Or yes, Quinn, would you like to add a little bit?
No, I just agree with Umar. I never want to move my hand down.
Okay, so let's proceed.
Yes, the locations of the working tent and food tent are not needed to solve the problem. Find the length of each side of rectangle ABCD. Use the coordinates of the vertices of the rectangle. What are the coordinates of vertex A?
Select your answer.
Annie, do you know what's the answer for what is the vertex of A? So we know that it's always xy, so what will it be?
-4 and 6.
So -4 and 6, we'll take this one, -4 and 6, let's see.
The coordinates of the vertices of the rectangle are A, -4, 6, B, 2, 6, C, 2, 1, and D, -4, 1. The distance from A to B equals the absolute value of -4 plus the absolute value of 2 equals 4 plus 2 equals 6 meters. The distance from B to C equals the absolute value of 6 minus the absolute value of 1 equals 6 minus 1 equals 5 meters. The distance from C to D equals the absolute value of 2 plus the absolute value of -4 equals 2 plus 4 equals 6 meters. The distance from A to D equals the absolute value of 6 minus the absolute value of 1 equals 6 minus 1 equals 5 meters.
I get a question. Why do you think that they're adding A and B, also D and C, but they subtracted the absolute value to find the distance between B and C and A and D? Do you still remember what we got from yesterday? Why do you think some we have to add and others we have to subtract? Omar.
I think there's some that we have to add. Some of them we have to add because,
for example, A to B, we're adding it here. Absolute value of -4 and absolute value of 2. We adding them. We add 4 plus 2.
Because
Why?
we have to find the distance from those two. So if we add them, we're gonna find the total. So that 2 is right. How much is gonna go down? That's like the x value, the y value, and then the -4 is also the y value. So coordinate.
-4 is the x. The x.
X.
Yes, so -4 is x and +2 is x. They are on the same spot on 6 of the y. All right. So the question is, why are we adding the absolute value of 4?
Total distance.
Okay, you get that idea for that. Selena, would you like to add on?
I like to add on. For some, we have to add because, like, for the negatives, we have to add, and then if it's a positive, and like A is bigger, like we have to subtract it because 1 is smaller, I think.
All right, Alana, would you like to clarify something on this?
Yeah, I disagree with Selena. You add because they're both in different quadrants. I don't know if I'm pronouncing that right. And then you subtract if the coordinates are in the same quadrant. And since A and D are in the same quadrant, you subtract while A and B are in separate quadrants, so you add.
Anyone else would like to add on to what they said? If you notice, like, we are going to find the distance between A and B, and it is separated by those axes, either y or x, but in this happens y. So we need to find the distance from A to that point and from that point to that point. All right, or you could just simply count over each other. But since we need to use the absolute value, we need to find the distance from this becomes your 0. So from this center to A, and from here where your becomes your barrier to the next one. That's why we're adding from here to here plus from here to here. That's why we add it when they are on different quadrants. We subtract it when they are on different quadrant because your endpoint is here, right? And you did not use that part. That is actually the part you're taking away. So that is 6 and that is 1. So you take away, you are going to subtract that to find that missing portion that we never use as a distance. All right? So
I see now.
Do you see it? So that's why we're subtracting it. That's why it's easier to think once they are on different quadrant, we add. But why they are in the same quadrant, we subtract because we're taking away that space we did not use.
So from A to D, we also have to subtract.
Yes, from A to D, we subtract. So 6 minus 1. 6 minus 1. But from D to C, that we add. Alright? So at least we clarify a little bit.
Explain why you add to find the distances from A to B and from C to D, but subtract to find the distances from B to C and from A to D.
We already tried to explain that one.
Points A and B and points C and D have the same y coordinate and are located in different quadrants, so you add the absolute values of the x coordinates. Points B and C and points A and D have the same x coordinate and are located in the same quadrant, so you subtract the absolute values of the y coordinates. Add the side lengths to find the perimeter of rectangle ABCD. Perimeter equals 6 meters plus 5 meters plus 6 meters plus 5 meters equals 22 meters. The archaeologist needs 22 meters of rope.
So there you go. So we're just gonna use our absolute value idea again. Alright? So that is the regular polygon. That was a rectangular shape. Let's go to the next one. So in this case, we're gonna be working on exercise 2, perimeter of irregular polygon. If you notice, the shape is a combination of two. So you could cut this into two rectangular shapes or a long rectangular shapes in that part. So that's why it's irregular. Okay? So let's see how we're gonna find the area or a perimeter, the perimeter of this irregular polygon. Sample number 2.
A rancher maps the coordinates for a holding pen for his cows. How much fencing does the rancher need to enclose the cow's holding pen?
So if you look over here, so it says click on the side to find the length. So you could click here, right? And see that what is the distance. But if you already noticed that the coordinates are here, and there's a clue or a cue thing that we need to look that the coordinates are the same. It means they are, the coordinates are the same. It means they are lying on the same axis or line. So we're just gonna take that and the absolute value of that. Since they are on the same quadrant, we subtract. Look over here, they are on different quadrant, M and N. So M and N, we are going to look, if you look, it's 4.5 and it's also negative 4.5. They are on the same axis, but the Y will be at 4 and negative 6. So absolute value of that, you add them up, right? The same thing, so you add all those 6 sides. Here you could just click it, but if not, it's in the next page. They're gonna give you the coordinates. You could use that too. So to add up all the sides, you're gonna end up with 81 yards of fencing. Let's look at the activity you're gonna be working in later on. So here you're just gonna, since you're gonna click this one because you had to work on it, so you just have to look at the coordinates of each, so A to B, and if you notice those are the Y coordinate is the same, so you're just gonna subtract the absolute value of 15 and 4.5 since they are in the same quadrant. A and H, you had to add them because they are on different quadrant. Okay. Question on exercise 2.
So do we go to do this in the SAVVAS now?
Yes. Let's look at number 3 first. Oh wait, let me see. So exercise number 3. So here,
Are triangle ABC and triangle BCD isosceles? Explain.
can anybody tell me what is isosceles? Do you still remember what it means? Any?
I think isosceles triangle is a triangle with two sides of equal length.
Correct. So, Selena, you have an idea what isosceles is?
Yeah, I agree with Kenny. It's like a triangle that has two same sides.
Sides that are equal. If you look at this picture, so I don't need the, you know that with sometimes you go to SAVVAS, there are this one, and they have, oh no, not print. They have the where did I go? They have that tool where you could say find vocabulary. You could use that. So
Oh, up there, like where it says
it's right here,
tools.
tools. I pressed the print, so I got it wrong. So you get tools here, you get English dictionary, and in that English dictionary you could find the meaning of let's say isosceles. So let's go to letter I, and I like this tool too. Sometimes I don't remember what it is. So here it can tell you.
Isosceles triangle. An isosceles triangle is a triangle with at least two sides that are the same length.
Two sides are the same length. So if you go back to our problem, so we'll need to check on how if these are isosceles. How are you gonna do that then? Annie, how are we gonna do it? How do we'll figure out that this ABC and these DBC are isosceles triangle, or ABC and BDC is BCD is isosceles? What are we gonna do?
You could use a project. I'm not sure.
What did we do previously?
Find the perimeter of the triangle.
Alright, so we're just gonna find the distance of BC and AC. If it is equal, then we could say that that's isosceles triangle. Alright, let's look at example number 2. Maybe they solve it for us. Oh, there you go. So if you look at the picture for A, the x is at -5 and C, the x is at 1. So remember, we adding them because they are on different quadrants. So AC, that's -5 over here, and 1 is right here. So absolute value -5 plus absolute value 1 is 6 units. We need to find BC. BC here. The BC is negative, the B is at 8 right here, and the C is at 2. So absolute value of 8 and absolute value of 2, since they're in the same quadrant, we take away the other side. So 8 minus 2 is 6 units. So we can conclude that I saw triangle ABC and triangle DBC are isosceles triangle. All right. So here, the problem you're going to be working on is you need to identify if they are quadrilateral. ADF is a square. Is ADFE a square? What is the characteristic of a square? What is the special characteristics of a square?
That all the sides are the same.
All right, you need to prove that by finding the side of the square. But before I let you go to work in SAVVAS, I'm just gonna explain your task number 2 for the project. You already did your map. So the second thing you need to do on that Google slide is you need to identify 10 landmarks out of your picture. Find their coordinates and then location in the quadrants. Is it in quadrant 1, quadrant 2, quadrant 3, 4, or is it in the x-axis and in the y-axis, or is it in the center? Okay. So question for the task number 2. We're just doing task number 2. You're not doing all of it.
In order to find our coordinates for the location, we need the coordinate number. So do we have to add all positive numbers or all negative, or some of them have to be negative numbers?
Omar, you should be in all quadrants. 1, 2, 3, 4. You have to spread your landmarks.
Yeah, they're spread. I'm trying to say, so For example, when we find our landmark, right? We
Yeah.
get the coordinates 4 and 5, -4 and 5. Let's say you got that right.
All right.
But then we need the coordinates. We need to place -4 on the map. So do we
You don't
place
need
all?
to you don't need to write -4 and 5 -4 comma 5 in your map. You need to write that on the slides that I posted in your homework. So if you go to your homework translate, no, this is not your class. So if you go to your class, I posted the slide where you could put your answer. So it's everybody has the access to the answer. So project map. So you already did. So I put hold on. I put a Google Slides there. Come on, what's going on here? Instructions. Here the map, right? And in that you could each one has a different each one has a individualized map. You have to do it. So here that's the title. So in the page 2, just upload your map here, take a picture and slide it here. Today this is your task number 2. You're gonna identify landmarks. So for example, post office, it is at -4 5. -4 5 is in quadrant 4. Next landmark, city hall, coordinate 0 0. Where is it located? Center, like that.
Yes, but the coordinates, right? So if we need to add the coordinates, right? We need to know the numbers. So
Just count them.
so
You start from the
are
center.
there going to be negatives in our?
If we divide the page into 4 quadrants.
Yes,
Yeah.
you should have your coordinate in 4 quadrants. You cut your graph paper into 4. So you have the
Yeah,
x-axis and the y-axis.
Yeah, I cut it into 4. So then in those 4, I need to add those tick marks, and then after those tick marks, I need to add the numbers like a -4, -5, -6.
You don't need to, Omar. You just find your center and just count. You don't need to really put the numbers in.
And do we need then? Are there going to be any negative numbers?
Yes, because you are going to use 4 quadrants to plot all your landmarks. You need to put 5 different places. I mean, 10, at least 10 different places in your map, right? Spread them all over your quadrants. Do you understand? Or should I show you an example?
I got it.
Okay. All right, guys, I'll let you work for the remaining of the time. I don't know how much more time we have. I only have a few minutes. So if you have a question, just raise your hand or just pop up. Okay?